Next, let's look at solving double inequalities. But really quick, I already mentioned this before, but just want to highlight this again. We need to use the symbol for union, again, to join solutions of a variable that are found in both two non-overlapping domains. All right, so a definition of a double inequality. So a double inequality is a compound inequality that's written in the following forms, which represent. So, here we have our variable x here in the middle, and we've got inequalities to either side. And so instead of writing our double inequalities, our compound inequalities this way with the word and, we're just going to be writing it this way instead. So whenever you see double inequalities written like this, we're actually expressing it as a compound inequality that way. So note that compound inequalities are treated like and not or statements. So how do we solve them? So to solve double inequalities, you solve for x in the center of the double inequality. So as one isolates x in the center, you're going to apply addition and subtraction, multiplication and division to the center, the left, and the right sides of the double inequality all at the same time. So let me show you that with this example. So here we have this double inequality. We've got -4 less than or equal to 3x minus 7 less than 8. So we want to isolate and get x by itself. So we're really going to be focusing here on this center expression. So if we wanted to get this by itself, one of the things we need to do is add 7. But we don't just add 7 to the right-hand side. We also are going to add 7 to the left-hand side. So here in the center, that's going to add to 0. And on the left-hand side, we've got -4 plus 7, which is +3. And now in the center, we're left with just 3x. And on the right-hand side, we're going to have 8 plus 7, which is 15. So notice that, the inequalities came straight down without being changed. And this is what we have left. Now, in order to get x by itself, we need to divide this by 3. And you guessed it, not only do we have to divide the center by 3, but also the right and the left sides also by 3. So these 3's will cancel, leaving us with just x. And on the left-hand side, 3 over 3 is just 1. And 15 divided by 3 is 5. So let's see how this looks on a number line, and then we'll write this in interval notation as well. So let's see, we've got 0, 1, 2, 3, 4, 5. And let's see here, x is going to be, so x is greater than or equal to 1. So if it's greater than or equal to 1, so if it's equal to 1, it's going to be a bracket, and it's greater than that. So we know we're going in this direction. And x is less than 5. So on 5, we're going to have parentheses because it's less than, not less than or equal to. And it's less than, so it's in this direction. So if we combine the more than with the less than, kind of join these two together, and that's the interval for our solutions of x. So x is going to be equal to everything between 1 and not including 5. Just like that. All right. So on the next page, we have 2 think pair shares. So give both of these a try. Solve it and give both the double inequality form of your solution, a number line graph of your solution, as well as interval notation of your solution. So give that here in these two.